Hello everyone and welcome to today's presentation. My name's John and today I'm excited to share with you some information on the tools that world-leading engineers are using to level up their product designs. First up, just a couple of things about VinZero. Here at VinZero, we foster innovation through delivering software and hardware solutions, consulting, training, development, and managed services. We've become a trusted technology advisor to our customers through the breadth and depth of our service, offering technical expertise, our commercial flexibility, and high levels of customer service and understanding. For those of you who are not aware, A2K is now partnered with several other strategic international operations from the US and UK and India and across the Asia Pacific region. We now are under the banner of VinZero and have a total of 550 employees globally and 32 offices and covering 25 languages. So we can leverage a large team to assist with your needs in these areas, whether it be on-site training, software implementation, content creation, so on and so forth. Just a couple of things about myself. I'm presently working with VinZero as an applications engineer, mainly focused in the mechanical space. My background is in the manufacturing sector. I started my career as a fitter and turner apprentice many years ago and have concentrated on a number of different aspects of manufacturing in the CNC space and also in hydraulics, pneumatics, machine tool design and manufacture, and a number of other areas. But for the past 15 years or so, I've been directly connected with the Autodesk line of products, and more recently a bit involved in the additive manufacturing space, which is a personal interest of mine. If you've got any questions as we go through today's webinar, please pop them into the chat in the Zoom panel. You'll notice a little option to chat there, and at the end of the presentation, we'll have a few minutes for further discussion. If there is any questions, I'll endeavour to answer those when we wrap up today's presentation. So the collection that we're talking about today is what we call the Product Design Manufacturing Collection. And it includes all the tools that you need to develop your ideas, to simulate them and to make sure that they work together, to analyze dimensional tolerances, to create CAM toolpaths and strategies, and factory layout options for optimizing throughput, and all the data for all those tools that are used to store and to manage that in a secure project. So Autodesk have a whole bunch of tools that fit into this sector, and it's my pleasure to be able to give you some information on each of those today. So we've got, like we said, areas where we can simulate and analyze dimensional tolerances, things like nesting and CAM functionality. We can also talk for a moment today about factory layouts and some of the things with creating an efficient factory. But best of all with these particular tools is that they're all included in the one collection of products. And we've got quite a list of software that's included in here. Obviously, most of you would be aware that Inventor is the sort of key product of this space, but obviously that also matches into a bunch of other Autodesk applications that link with Inventor to give us some very high-end information and data on the various aspects of working with the Autodesk solutions in the product and manufacturing space. So in those capabilities, we can certainly see many applications that are available to us that help us be more innovative. We can win more projects and business. We can streamline manufacturing. We can improve our overall product performance. And we're going to show you today during the presentation some of the reasons why and how we can achieve that. So first, in regard to your design solutions, we've got a number of options here for when we start out with Inventor. And as you would probably be aware, the general capabilities of Inventor, they're quite well known, and we certainly run webinars and training on the Inventor product quite frequently here at VinZero. So I'm going to just quickly brush over a couple of points before we dive into some other elements of the Autodesk Product Design Manufacturing Collection for today's webinar. So with regard to Inventor, and I'm sure many of you would be aware of a lot of what Inventor does, but it certainly enables the designer, maybe yourself or the engineer, to focus on the design, less of how to use feature controls, but more on the concepts and the power of the design that you've got. So because we're going to find specialized modeling tools, we can speed up our design and integrate things like sheet metal tools into our product design. And those are, of course, available for us as a feature of the Inventor default system. These are not extra add-ons that you're having to purchase. They're all included in the software. So we can certainly, with sheet metal, obviously create flat patterns of items ready for laser or plasma cutting or profile cutting, whatever you're doing there. And they can certainly help streamline that process. There's a great little tool that many of you would be probably aware of, is the frame generator. Fantastic part of Inventor's assembly design, where we can create a skeletal structure and then add cross sections or RHS members or whatever it might be to that particular structural steel shape. And then we can work with that. We can also simulate those items and do some stress analysis in the frame environment to allow us to see how that's physically going to manage within our particular design. We've also got the tube and pipe side of Inventor, which is a very powerful module for animating and creating things like hydraulic hose and fitting design, and also pneumatics and or any product flow type scenario, where we can create routes of piping systems with automated fitting placement and things like that are very, very powerful and allow us to work and create and complete those projects in very short space of time. And of course, we've got the flexible modeling tools that are listed at the bottom there. We've obviously got three main areas of Inventor. We've got parametric modeling, direct modeling, and free form modeling. And basically these three environments are all within the one Inventor product. So we can utilize all three of those interactively. We can work with parametric modeling and then switch into the freeform mode and use a push-pull type design system, sort of like plasticine modeling, if you like, and we can use all of those areas of the Inventor software together. Another very powerful aspect of Inventor is what we call iLogic. Now, iLogic is a very, very powerful system where we can set up rules which control the way that our design is going to behave. And a very interesting and powerful system to allow us to reduce repetitive tasks. We can obviously make minor changes and or major changes for that matter to our design to create items that are directed by certain parameters, and we can then build that in. And in the Inventor 2023, we've seen a number of nice little enhancements to this area where we can save out our rules to a menu system and make good use of them. So if we use, even for generating quotes and things like that, if you've got a conveyor system, as you can see there on screen, we can very quickly animate or sequence that conveyor system up, and we're able to get our data out more quickly from our design and apply a rule to that particular system. One of the other things that Autodesk have included over the last number of years is in the interoperability situation is obviously working with data from other CAD systems. And this has always been a hurdle for many companies. If you talk to any engineer, when it comes to sharing information from one CAD system to another, we lose all sorts of information. But nowadays, Autodesk have created a part of Inventor software called AnyCAD, which is a very, very powerful little tool that basically reads in data from a range of different CAD systems and gives us the option to be able to work with multiple CAD systems, and even being able to maintain an associative link to, for instance, a CATIA design or a design from another system. So if we update the native CATIA design, Inventor can react to that and obviously allow us to see that update progress through the system. So quite a powerful little tool worth exploring is the AnyCAD functionality. Basically, as soon as you open any one of these models from another CAD vendor, you'll get prompts as to what you would like to include inside of your design functionality. Something else that's grown quite a lot over the last number of releases is what we call BIM interoperability. This is a very powerful part of the Inventor space and allowing us to interact with other elements of software, specifically and particularly for those people who are in the architectural space using Autodesk Revit. Very, very powerful functionality now to be able to collaborate with architects and to allow those custom options and items be inserted into a building design, and we can then use those quite easily to create and export out of Inventor as an IFC or an RFA file for use within the Revit space. So we can quite quickly simplify the model. Obviously, as you'd be aware, an architect probably isn't really concerned about what's inside the air conditioning system, as you can see on screen there. All he's really interested in is the details, maybe the vent outlet, inlet positions, etc., where the services connect in. But in Inventor, we obviously would have all of the manufacturing details. So we can simplify or dumb down our model. So these can be used quite cleverly within the Inventor and Revit space in that fashion. So yeah, quite a handy functionality that we're seeing a lot more development on in that sense. So let's talk about some of the integrated tools. And again, all of these tools are part of the Product Design Manufacturing Collection. These are what we call extended capabilities of the Inventor tool. And first up, I'd like to talk to you a little bit about tolerance analysis. Now, for anybody that's been involved in the manufacturing space, you'd be well aware of the extra cost involved in creating, for instance, a super finished lapped part compared with something that's flame cut. So obviously there's extra manufacturing processes that need to take place, and that will obviously impact on the cost and quality of your design. So I guess the big question is, how much time and money are we spending unnecessarily creating high quality finishes when maybe the customer isn't really needing that particular functionality? So really the purpose of the tolerance analysis tool is to show where we need to have high tolerance items, and we can certainly stack those tolerances up and look at the way that we can analyze all of that within our 3D model space to consider best fit, function, and form. So obviously we've got quite an important, and we'll come back to this one in a later slide. I'll be talking a little bit more on this one as we work through today's presentation. With regard to factory layouts, and this is another part of or an aspect of the Product Design Manufacturing Collection that links into Inventor. And I'm not sure if anybody's looked at this, but we have done webinars on this particular subject specifically. And yeah, if you're interested in this aspect of factory design, certainly worth having a look at those particular webinars, and I'll explain a little later on where you can get access to those. But basically with the factory design tool, we've got an option where we can bring in from a very large library of standard components. So things like conveyors and basically anything for product movement, we can save out and create an asset library which lives inside of the Inventor system, and we can simply pull in conveyors and product movement modules to allow us to set up basically a map of where our part is going to travel through a production type scenario. And then we can analyze the physical aspects of that and the associated costs associated with each of those production scenarios. So there's quite a lot of benefit in doing this, and certainly having a great design. Obviously, we need to be able to produce that part and have it come through a production environment, and we can do some further analysis on that within the Inventor factory layout or factory design utility. We've also got options for things like stress analysis, and most of you would be aware that many of today's 3D CAD packages include some sort of entry-level FEA, finite element analysis tools, and lots of people use these, which is great. But every license of Inventor Professional has a sort of a standard stress analysis for standard stress and frequency studies. But also within that, if we have the product design manufacturing collection, you get access to what's called Autodesk Inventor Nastran. And that offers a more complete set of simulation studies. So we can do nonlinear, thermal, fatigue, and dynamic studies. And they all offer a complete understanding of what your product performance and the accurate results that you need from that particular product. And really what makes them so powerful is that all of the calculations here are using the Nastran solver, which if you know anything about FEA, is quite a powerful solver that is owned by Autodesk. Another really powerful part of the product design manufacturing collection is what we call Inventor CAM. Now, this is an area that I've been quite involved with over the years, but it provides for us a seamless workflow from design through to manufacture. And because it's integrated into Inventor, it means that the changes that you make to your Inventor model will reflect instantly in your toolpath and CAM processes. Now, this has always been a challenge for people using CAM software, in that when a change is made to the parent model, generally they would have to re-import the parent model, go through and reprocess their CAM toolpaths. With Inventor, it simply pops up with a little message box saying, your model has changed. Would you like the toolpath to reflect that change? If you pick yes, the system goes off and rebuilds the CAM toolpaths according to the change to those particular those models. So yeah, quite a powerful tool that gives us quite a lot of options for working with connected designs. And again, a lot of what we're talking about today is about reducing what's commonly referred to in the industry as silos of information, where we end up with one person doing the CAM system and another person doing the 3D design. Basically, these are all rolled into the one software if you're using Autodesk's product design manufacturing collection. Moving forward, the next little functionality that I'd like to talk about is the nesting function. Again, this is a system that links into your Inventor software, where it just presents as another tab along the top of your Inventor, where you can go and run a nesting analysis by saying that I want 10 of these brackets and 5 of those brackets and 3 of those brackets. What the nesting software will do is look at the thickness of each of those brackets or items that you're requesting. It will then lay them out onto whatever sheet size you specify, and lay them out in the most productive way to optimize your material usage from that particular sized sheet. So the nesting studies are very, very powerful, and obviously we can just export that straight out then to a laser, plasma, or profile cutter to create toolpaths that are going to give us the best utilization of our raw material sheet. So a very, very powerful tool. This is fairly new to a new tool. It's not been around for, I think it was released 5 or 4 years ago with regard to nesting. So something else, and again, all linked in with your Inventor model. So if your Inventor model changes, obviously you'll get a message in the nesting software to saying, this profile has changed. Would you like me to rerun the nest? So very, very powerful functionality that we can utilize within Inventor's menu system. So just back to one of the items that I talked about before, and I mentioned we would come back to this. I want to talk for a moment about tolerance analysis. Now, tolerance analysis inside of Inventor is a very, very powerful thing. And simply put, it allows you to make trade-offs between manufacturing and assembly tolerances to reduce costs, while ensuring that you've got a correct fit for your particular gearbox or whatever it is that you design. And if ever you've had to do this manually with a spreadsheet, you'll know it is very time consuming. It's not an easy function, and it's quite often prone to errors and challenges as you work through design. But the best part of tolerance analysis is that it's built directly into the Inventor user face. So we can check stack up of tolerance capabilities and relationships defined in the assembly model. It then calculates the cumulative effect of the geometric dimensions and tolerances included in the stack up. So tolerance analysis associatively reads the tolerance values that you've already specified when you applied the 3D annotation to your model to create model-based definitions, including geometric dimension and tolerancing. So tolerance values can be evaluated and edited directly inside the tolerance analysis panel, and any updates automatically stay in sync with your existing 3D annotation and GD&T. Tolerance analysis helps you to understand how contributing tolerances impact each of the stack up loops, and we can calculate that and view that as a worst case scenario and output that in statistical information in relation to how that behaves. So if you're not already doing 3D annotation and GD&T, have a go at it. It's a very, very powerful tool, and it will leverage your existing design information and show you how those tolerance analysis can be considered. These tools allow us to save time in manufacturing by machining parts at a lower and acceptable tolerance. It reduces costs over tolerance components and ensures, as we've said a couple of times, correct fit and function for the final design. So very, very powerful tools that, yeah, I'd certainly encourage you to explore and take a look at. As we mentioned before, just like the tolerance analysis, Inventor Nastran is built directly into the user interface also. So setting up an analysis is easy. You're going to start out by choosing the type of analysis that you want. Then we obviously apply a material to that. We set up whatever material we'd like from the library. Now we can define our mesh settings, and basically we can go and stipulate the mesh size and look at how that those items are all going to function. We can then, and they're really the two most important pieces of information when it comes to running analysis. We set up a series of constraints, and basically where we're going to maybe bolt that part down, and then effectively the real world conditions are applied to that component. Once these are all set up, we can run our simulation. And after the simulation is complete, we can then inspect the results in a number of ways with color plots or animations. We can look at minimum and maximum values and a number of other items with regard to how that works. And the really cool part about this is that when we make a design change, in this case, we had to add that center rib, we can obviously see the impact that that is going to take on our particular part or component. So all of that setup carries over to run an updated simulation of the new geometry, giving you a very good comparison of one design to the next. Again, an integrated tool that's built into Inventor, so as we can do some fairly high-end analysis on our componentry when it comes to the production side of things. So I'd like to talk for a moment, and this space has been growing quite a lot over the last number of years. We're finding a lot more integration, and as I mentioned previously, obviously with BIM and interacting with Revit and the likes of those tools, there's a bunch of options with regard to working with connected design, as we call it. So whilst 3D CAD software provides and encourages you to, you'll often hear the thing, you should move from 2D to 3D. And that is true. There are many, many benefits of a 3D workspace. However, in some scenarios, you may find that using some elements of 2D are still valuable for your particular situation. So things like electrical schematics and things like that are best off done in a 2D environment. There's some aspects of manufacturing that still lend themselves to simply a 2D space, but why not interconnect that? So why not link that up with your 3D model so we can use elements of our 3D space and elements of our 2D space to delve in greater detail to how these can interact together. A couple of other things about connected design, and most of you would have heard of a product called Navisworks, and again, a very, very powerful system for looking at doing clash detections and a number of other areas. Basically, the purpose of Navisworks is to manage large designs and items that might have thousands or millions of components. But Navisworks is a very, very powerful tool for doing things like clash management and walkthroughs and fly-throughs. So we can do a lot of design review in the Navisworks system. But again, that links up with our Inventor system to allow us to work with those particular items. So things like simulation of a factory layout as your part moves through its production life cycle, we can certainly see the part travel and move into particular environments. And maybe a part spends 4 hours in this particular area having so many processes applied to it, and then we can move it on to the next cell or whatever it might be for the production functionality. I did mention schematic design before, and there's some very powerful things going on in the electrical space. Inventor does have a cable and harness system, which you may or may not be aware of, but really collaborating between mechanical and electrical teams can be a challenge sometimes. There's no doubt about that. So being able to work with electrical and mechanical designs, we can actually get them to talk to each other in that sense. So AutoCAD Electrical can actually link up with what we call the electromechanical link to Inventor. So we can share 3D models and live links between those particular applications, and that will give us some very, very powerful functionality working between not only the 3D modeling processes that you would normally have within Inventor, but also for analyzing some of your electrical details and creating your schematics. And again, they remain in sync with each other. So there is a live link between, for instance, AutoCAD Electrical and Inventor, if we wish to use this electromechanical design link, a very, very powerful tool that if you're using AutoCAD Electrical or Inventor and you're doing electrical design, certainly worth exploring what that actually does. Now, with regards to making your design look great in front of your customers, and again, I'm sure some of you have heard of 3D Studio Max, which is a very, very powerful tool that is obviously used quite a lot in the media and entertainment space these days. There's a lot going on, and many of the blockbuster movies that you've seen over the last 10, 15 years have probably been created using aspects of 3D Studio Max. It's a very powerful tool. I will admit it takes a little bit to learn 3D Studio Max, but if you've got an interest in 3D rendering and life cycles, as in cinematic design and realistic renderings of your model, certainly worth having a look at this. 3D Studio Max is included in the product design collection, and you can certainly use it to create some very realistic marketing information and other details to make your products look amazing in front of your clients. And we'll go back to this one a little later on as well. That's another area that I'd like to talk about. One of the other things that's grown quite a lot over the last number of years is using point clouds to create different details and creating scans of areas. And you might be a building owner and want to make sure that your new equipment coming in to this new property is going to fit correctly and function properly. So yeah, there's a lot that we can do in this particular space by working with point clouds. And you will see more and more of this, I believe, as time goes on, because we can obviously scan a building, use different points from that scan to actually create information for working within the system. So if you've not looked at this, there's some really clever tools within not only Navisworks, but also a product called Recap for working with scan data. And obviously we can then link that and import that into Inventor or AutoCAD or whatever software you're using to be able to work with your complete 3D design. So obviously the one of the big benefits of this is we can very quickly and easily see in real time how particular work cells might fit into a factory or whatever it is that you're designing. So we can certainly work with those 2D and 3D layouts with our point clouds to see if we're going to physically be able to fit those particular details into your workspace. So just one other little slide. This one is related again to 3D Studio Max, which I mentioned earlier. Again, a very, very powerful system that allows us to work with realistic renderings and some very, very powerful tools that allow us to use cinematic quality to create workflows within a factory, for instance, or to utilize the different information. So again, connecting our Inventor data with our marketing information or information about maybe a factory layout or something that we've done to that extent. With regard to Fusion, and many of you would be aware already of what Fusion does and how it functions, but there's been some really nice design developments and interactions in the Inventor and Fusion space, particularly in the 2023 release of both of these softwares. There's been some really fantastic little tools that are available to us now. And one of those that you may or may not have come across in the past is what we often refer to as generative design. It's a very powerful system that allows us to do design studies on how things are going to function in real-time space. And in actual fact, the part you can see on your screen at the moment is from General Motors. It's a seatbelt bracket, as you can probably recognize. And obviously with the onset of 3D printing and some of those functionalities becoming more orientated around printing materials and metals and different types of products. So again, some of these items, quite powerful. So the bracket on the left was made up of 8 separate components that were all pressed metal parts that needed to be fabricated together and created. And basically, by going this track and using additive manufacturing, they were able to create a bracket. And I believe this is actually a part that is physically used by General Motors Holden now as a way of sorry, not General Motors Holden, by General Motors as a way of bolting their seat belt brackets into one of their vehicles. Again, metal 3D printing is becoming quite a common thing these days. In actual fact, A2K did have a 3D metal printer set up here in Adelaide, and we printed some, very impressive stainless steel parts, some parts out of Inconel and A2 and D2 tool steel. Very, very clever and very good functionality. So that technology is certainly available and coming down in price. The more people use it, obviously, the more we're seeing those price points reduce. So quite a powerful functionality. We're also able to print in pure copper and some of those exotic materials that are rather hard to machine or hard to work with in a machining or a subtractive manufacturing environment. Okay, with regard to CAM, just again to talk a couple of other elements of this. And look, there's plenty of times when we do need to still use subtractive manufacturing. So when we talk about additive manufacturing, we're talking about 3D printing. Subtractive manufacturing is traditional manufacturing methods where we get a block of steel and machine segments of that away to create our required part. Now, again, Fusion and Inventor both have the functionality to do either of these, whether we want to do a quick prototype on a desktop printer, or whether we're ready to take our part out and machine it on a CNC machine. And yeah, we can do both in the same application. And so that's where we find, yeah, quite some good interactivities between not only the 3D print space, but also going off into the CNC space and looking at profile cutting or machining, milling, mill turn machines, et cetera, and for some of those different elements of our machining functions within not only Fusion, but also within the Inventor scenario. Again, Fusion also has a, a very nice little feature within it to allow us to design electronic PCBs, et cetera, and work with those. So you may be aware of the electronic system within Fusion 360. This is quite a powerful little tool, not something that's available in Inventor at this point, but I think in time we will see some of those options be included in that space. But yeah, quite a nice little tool that enables us to design a printed circuit board or whatever it might be, working within the Fusion tool. With regard to interacting and working with Fusion, there's quite a lot of linkages now, and I had hoped to give you a bit of a live demonstration on this. But yeah, basically inside of Inventor, we've got a whole bunch of tools now where we can yeah, work with Inventor to allow it to send our model directly out to Fusion. I will just quickly fire up my Inventor and show you this one. I think this is quite a powerful little tool that yeah, that allows us to work with interactions and working with the likes of a Fusion system. So inside of Inventor 2023, which I've just fired up here, we've got this new tab now where we can connect our design directly with an element of Fusion, whether it be additive manufacturing or subtractive manufacturing. So you can actually link your Inventor model directly back to Fusion for looking at a whole bunch of different options. So if we're doing some in plastic injection molding, we can link into the system for that. So it, yeah, quite a powerful tool for working with this. And when we open up any one of these, so if I was to go and say I want to load this into Fusion's subtractive manufacturing environment, we can certainly go in here. Basically, this will allow us to upload to our Fusion cloud storage space and work with that particular item. So yeah, quite a powerful tool that now links Inventor and Fusion together, and we can utilize that as far as using the that particular design. So what this will do is send this particular part I've got in my Inventor at the moment up to my cloud storage inside of Inventor, inside of Fusion, and allow me to go ahead and create some CAM files or whatever it might be that is linked into the system with regard to working with each of those items. So a very, very powerful functionality that, yeah, very worth exploring if you're using Fusion CAM at the moment, which again, a lot of people have been doing over the last years, just because of the ease of use and the great functionality that you've got within Fusion. So yeah, just another option to link your Fusion and Inventor systems together. Couple of things here just with regard to some further information. If you'd like to research any of these, again, the links on screen at the moment will be very helpful for you. There's quite a bit of functionality with regard to the different elements of the Autodesk Inventor linkage to its other tools within the design and manufacturing collection. So thanks for joining us today. I hope what we've talked about has been helpful. If you'd like to see any of those other webinars that we're doing in the near future, please go to the link on your screen. You'll find there's there's some details on those, and you'll find also, if you subscribe to our YouTube channel, all of our previous information and details are available at that site. But if you'd like to get in touch with A2K, feel free to use the email address on your screen, info@a2ktechnologies.com.au. Be more than happy to chat further with you about the either what we've talked about today or any aspect of the product design manufacturing collection or the architectural engineering collection. There's a whole bunch of tools in there that are really worth exploring. So yeah, thanks for your time. Thanks for joining us. Stay safe and well. And if there's any questions that pop up in the chat, I'll stay online for a couple of minutes just to answer any of those if there is queries. So yeah, thanks for your time today, and no doubt we'll be in touch in due course.